Joule Breadmore. My equation was y equals -1 plus sine x minus pi over 2. The transformations from the parent graph to this graph are a reflection over the x-axis, up 1 unit, and to the right pi over 2. The amplitude is the absolute value of a. In this case, a is -1, therefore the absolute value of -1 equals 1. In a sine graph, the period equals 2 pi over the absolute value of b. In this case, b equals 1, therefore 2 pi over 1 equals 2 pi. Phase shift will always equal -c over the absolute value of b. In this equation, c is already negative, therefore making the negative c a positive c. So, c is pi over 2, and again, the absolute value of b is 1. So, pi over 2 divided by 1 equals pi over 2. To get from the parent graph points to the new graph points, pi over 2 had to be added to x, and y was multiplied by -1 in addition to adding 1. To make the new graph, I have marked the points of the x-intercepts, maxes, and minimums. What I have then drawn is 2 full periods of the function. From pi over 2 through 5 pi over 2 is 1 period, and from 5 pi over 2 through 9 pi over 2 is another.
Hi, I'm Nikki, and I'm going to explain my cotangent problem. The parent function is y equals a cotangent bx plus c. I was given the function y equals 3 cotangent x plus pi. The transformations are expanded vertically, which you get from here, and left pi, which you get from x plus pi. There is no amplitude because there is no waves, and only sine and cosine have amplitude. By using the equation to find period, I took pi over absolute value of b and referred back to my given function, and when I plugged b in, I got pi as the period. I used the phase shift equation and referred back to the given function to get c and b. When I plugged pi in for c and 1 in for b, I got -pi as the phase shift. I took the coordinates for the cotangent function and made a table. This is the vertical asymptote, intermediate point, x-intercept, another intermediate point, and vertical asymptote. I went back to the transformations and got x minus pi and 3y to plug into the table for the x and y values. You take these values and graph them, and I graphed 2 lines that indicate 2 full periods.
Hi, my name is Mindy Mabry, and I'm going to be presenting to you how to graph this function. We are given y equals 1 minus c of c times x over 2. We looked and we found the transformation up 1, reflected x-axis, and expanded horizontally. We then looked and we found that there is no amplitude because it doesn't contain a frequency. The period we found from the equation 2 pi over b, which we found to equal 4 pi. We then found the phase shift from the equation -c over b, which we found equals 0. We then looked at our parents and jotted down the points of which the vertical asymptotes, relative max, and relative min come from. We then looked at our original equation and made up a new one for our graph of 1/2 x -y plus 1. We multiplied 1/2 times -x to get -pi over 2. We multiplied 1/2 times -pi over 2 to equal -pi over 4, -1 minus a negative plus 1, so we found the y point of 2. 1/2 times 0 is 0. Pi over 2 times 1/2 is 4 pi. -1 plus 1 is 0. And pi times 1/2 is pi over 2. We then plotted these, our vertical asymptotes first starting with -pi over 2. Our next vertical asymptote would be 0, which is your x-axis. Then your next vertical asymptote would be pi over 2. We can then see that there is a pattern of having a space in between each vertical asymptote. So there would be pi in between. So we were then able to graph all of our next vertical asymptotes. We then went in and plotted our points of negative pi over 4, 2, pi over 4, 0, and since that it's a pattern, we were then able to plot them at the given spots. We were able to put this as going up and this is down because, as you can see, it transformed to up 1, so the horizontal asymptote goes up 1 and stays right here. This is how we graph this function.
I'm Taylor Lukasic, and I'm going to show you how to interpret and graph a trigonometric equation. My original equation was y equals negative 1/2 cosine times pi x. To identify the different components of the equation, we refer to our formula. Looking at this, we can clearly see that a equals negative 1/2, b equals pi, and there is no c or d. The transformations from the parent graph to the given function are as follows. Reflected over the x-axis, compressed vertically by factors of 2, and compressed horizontally by factors of 1 over pi. The amplitude of a trigonometric equation can be identified by simply taking the absolute value of a, which in this case is 1/2. The period is identified by the equation 2 pi over the absolute value of b. In this case, the absolute value of b, or pi, is pi, so 2 pi over pi is 2. Because there is no c in the equation, there is no phase shift. To get from the parent graph points to the new graph points, x was multiplied by 1 over pi and y was multiplied by a negative 1/2. Finally, to make the new graph, I have added the points of the x-intercepts max and minimums. What I have then drawn is 2 full periods of the function. From 0 to 5 over 2 is 1 period, and from negative 5 over 2 to 0 is another.
Hi, I'm Nikki and I'm going to explain my cotangent problem. The parent function is y equals a cotangent bx plus c. I was given the function y equals 3 cotangent x plus pi.